just out on a drive, and everything is going good. No faults. So definitely calling this a fix. Welcome back, everybody. Hopefully you enjoyed part one there. I already got the engine computer out. I did forget to show you one thing that I'd already checked. So with the ECM responsible for pulling that circuit to ground, what we're seeing in the waveform is essentially a high resistance to ground that is causing it not to be able to pull it down, whether it be high resistance in the driver itself or something within the circuit board or whatever. So something I did do the first day I looked at this thing was test the engine grounds. There's only 3 of them. I'll show you a picture of the wiring diagram, and they're all 3 in this one connector, and all 3 pretty much right here together. So you got 50, and I believe it's 69 and 70 right here. So what I did is I just took my 10 amp test lot and pinned it in each one of them and touched it to battery positive. There you go, you can see that's bright. Let's go to this one, that's good. I guess I was touching over there. And the third one here. So there you go. You can see all 3 of them carry a pretty good load, so I'm not too worried about any of those being the issue. So what I was talking about at the end of the video is I need to know how much current it takes the ECM to pull that 12 volt circuit down to ground coming from the fuel pump control module. So what I'm going to do is turn the key on. I've made a coil loop, a 20x loop, to basically measure the current that it's going to take to pull this circuit down through a 194 test bulb. So let me get all that together and show you. Okay, so what I've got the key on, and I'm pinned into my FPC wire here. And what I've got is a 194 bulb that's going through my 20x loop here with the amp clamp on it. So basically I'm going to ground out the FPC wire to see how much current flows through. And as you can see on the scope, we're right at 100 milliamps. Divide that by 20 because we're going 20 times through the amp clamp. So that puts us at about a 5 milliamp circuit. So now I need to basically figure out how much of a resistance do I need to add in here to make this bulb only pass 5 milliamps. And I have a pretty big selection of resistors, so just kind of going through some of them. That one, not quite there. Ignore the voltage trace, we're just looking at the current. So that one is just barely over. We'll keep that one set there. And I feel like as long as it's pretty close, that one's way over, we'll be okay. So just run through a few of these. Oh, that one's way up there, so nope. I just basically just grabbed an assortment. That one's kind of close, so we'll set that one there until I got some that I thought would be close. Oh, look at that. That one is pretty much dead on what we need. So that's the one we'll use. So what we'll be doing is passing 12 volts through the resistor, through the bulb, into our engine computer to see if it can pull that to ground. Okay, so here we have the ECM out on the bench, and this would be the part number, that 9L3A 12A 650 BXA. So now all we need to do is just clean all this up and get all the dirt off of it, spray paint it silver and put it back in there, and then it's refurbed, right? No, I got the screws out of it. I'm gonna have to heat this thing and separate it, and then we'll get in here to the board and see what's going on with it. Well, I got the back cover off of it, and I noticed something. When they assemble these things, see, they've got these little locator pins so they can sit the board in here. Oh man, must have been a Friday job. Yeah, that one got crushed in there. Surely that's not going to be part of our issue though, hopefully not. But our pin that we're worried about is this, let's see here, the second one right here. So that trace kind of goes up and around over here and then through the board right there. So hopefully this ain't going to be an issue, but yeah, somebody messed that one up when they put this one together. Okay, so I got the board out and kind of looking the whole thing over pretty good, and at first glance I seen this little black spot here, and at first I thought it might have been a Sharpie mark, but yet there's no other Sharpie marks like that on the board. So put it under the microscope and it actually looks like some kind of corrosion, and it's over here on this side of it as well. Let me try to get the lighting a little better on this. Okay guys, I apologize. My microscope last night, even though it said it was recording, it wasn't actually recording. I don't think it liked my big memory card that I'd put in there. So I found a smaller one, tested it this morning. It seems to be working. So I'm going to go over kind of everything again that I did last night, and just kind of show you what I found, what I did. So I traced the circuit to this chip right here, which is a just a low side power transistor or MOSFET, and the pins here is 1, 2, and 3, input, drain, and source is internally connected to tab, and these are grounded, and this goes out to our fuel pump module to give it that pull to ground duty cycle, and it is triggered by this. This right here is actually able to carry a little over an amp, so this chip can easily pull that circuit down. So my thought now is that this chip isn't actually pulling to ground because it's not duty cycled on long enough, and I traced this up through here, and this in here is where I had all that black corrosion looking stuff. So our trace comes under here, goes under this little resistor here, under this chip, which is a Schmidt trigger, over here to pin 3. I actually took this chip off and this resistor off last night and cleaned under it all, make sure there wasn't anything under there, and this trace does go down to pin 3. Pin 3 is the output of either 1 or 2 or both. So as you can see, they're connected together here. So these two basically are switching on to number 3, and at rest, number 3 is connected to pin 7 here. Yeah, pin 7, which is ground. So basically this little chip here is outputting here through that circuit trace down to our MOSFET here, and this MOSFET is then running out to our fuel pump control module. So the issue, I believe, was just this corrosion had ate through the top coating here and causing these three to kind of short together a little bit. This corrosion come out of this cap. Well, technically it was this cap right here. Let's see if I can get this on focus a little bit. That cap. When I started looking and cleaning really good, I noticed this corner of it was a little melted looking there. And that corner is this corner right here. Basically right where all that stuff had come out. So I determined that this cap failed and basically leaked its juices out and caused the board to corrode right through here. So I've got all that cleaned up really well, and I got it as good as I could. I also cleaned on the other side of the board where it had run down through these holes right here. Cleaned this side up really well too. So what I'm going to do to kind of protect this now, because these traces are exposed now, so we're going to clean that off really, really good and reseal it. And I just use some clear fingernail polish, so seems to work pretty good. I also use it over here on the board where I clean off the heatsink glue, basically, that they use, the thermal paste glue. Sometimes scraping it off kind of makes some of the copper come through. I don't know if you'll be able to pick that up too well or not, but so I'll coat all this except for these little tabs. These tabs are actually meant to be grounded, so they're okay if they touch ground. So but I'll go over all these other traces with a little bit of clear fingernail polish to coat all those and protect them. Still got to clean that side off and that side, as well as cleaning the case where the case glues back together and stuff. So we'll work on that this morning. Sorry my thing didn't record like it said it was. I should have checked it, I guess, before I got too far into it, but it was flashing like it was recording, so I thought it was good to go. Apparently not. But anyways, let me get this all cleaned up and carry on with it. I've already tested it in the truck. It does run just fine. So let's get this thing put back together and throw it in the truck, and we'll take it for a test drive and make sure everything is good with it. Okay, so I found a capacitor and got it on there right here. And the easiest way to check this thing is just really just plug it up, probe it, make sure we're not touching anything metal. This is plastic, so it's fine right there. Let's get y'all guys. I'm just gonna set y'all up here to watch the scope. I'm gonna go just turn the key on real fast. Let's see what happens. What happened? Did it do it? Let's see. Look at that. There's our 12 volts. And this is with the pump running. I can tell because the current's got the voltage down. Pump turned off here, so it probably hit pressure. You can also see the pulse width change here. So see how I got a lot narrower right there? So that basically triggered the pump to turn off. And then I turned the key off. Pretty cool. What do you guys think? Is it fixed? I think so. I think it's a pretty good chance that it's fixed. So I'm gonna take it back off. Finish cleaning off this old residue, this glue that they use for heat sink stuff. I just kind of spray it with some solvent, and it brushes off pretty easy. It takes a little bit of time, but I'll re-glue it with some. I won't actually use glue. I'll use some I think it's called Arctic Silver. It's just thermal paste. Same on the other side here behind these chips, and this side over here. You got the same stuff. So I'll get the board finished cleaned up. I'll get the case cleaned up. Get it all put back together, and we'll get this thing back in the truck and see if it's really fixed or not. Okay, got my board cleaned up, and I went over with my clear pheno polish and basically just kind of protect the small traces and stuff. And even right here where my issue was, I put an extra 2 coats right there, make it nice and thick. Got my case all cleaned up, and one thing you can do is you can actually just put these things together without gluing them. You can put them together and throw them in the vehicle and test it out before you glue it together. You'd want to make sure everything works, make sure you didn't damage something you didn't notice. So that's what I'm going to do. I'm going to put screws in this thing, throw it in the truck, take it for a drive. The parts where the thermal paste are supposed to go, I'll take and just put like a little dab in there to give it some thermal transfer. It won't take much for as little bit of a drive as I'm going to do. So that's kind of a little secret tip you can do. Just throw them together, put them in the vehicle, drive it, make sure everything's good. And then once you verify that it is, take it back out, then really do your thermal paste like you need to, and you can glue the case shut and put it back in permanently. Well, she's running, and so far ECM doesn't have any codes in it. Ignore that. It's before I had the ECM unplugged. Same with all these other ones. And if we go over to our scope, come on, look at that. Nice waveform pulling the ground. Perfect. So I'm going to take this thing for a little drive around the block, get good and hot, make sure everything is still good, and then I'm going to seal that ECM up and get this thing back to the customer. So if this is the end of the video, then everything went well, and I hope you guys like this. Sorry, my scope didn't record correctly. Sorry about that. And it turns out we didn't need to do any load testing on that driver because we just kind of found what the issue was. So hopefully you guys liked it though. Hit that like button, hit the subscribe button if you found it helpful at all. So see you guys next time.